Hello class, this is case study for part 2. Today we're going to wrap up our question, which is it possible to have zero impact? And we're going to focus first on what is in our trash bins. So in addressing this question of if it is possible to have zero impact, we've already looked at the urban habitat and our water consumption. Now we're going to focus on the trash bin that we have in our day-to-day lives. So when we talked about water issues, we did address fecal waste and other human waste and how that can sometimes pollute our water systems. But what about solid waste? Things like plastic or paper or other types of waste we generate every single day. Well, the first question I would ask you is, where is away? We often say, oh, I'm going to throw that away, and then we never have to think about it ever again. The services that are in place contribute to our quality of life, but it really separates us from the process where these waste items end up. So let's talk trash. This shows us a map of the peninsula just south of San Francisco, and we can see that much of San Mateo County is served by diverse trash providers. So there's quite a few different sanitation companies that deal with our trash, our recycling, and our compost. So what exactly is in our trash bins? This figure replies to what's called municipal solid waste, which is abbreviated MSW. So that's the trash that we throw away as citizens. And you can see that most of what we throw away before recycling is actually paper. 31% of our trash bin is filled with paper that otherwise could have been recycled. And the next biggest category is yard trimmings plus food scraps. So this is organic waste that could be composted. And finally, approximately 12% of our waste bin makes up plastics. And how much do we actually have in terms of the amount of trash? Interesting that per person, we are doing pretty good in the United States. We're diverting waste and we're increasing recycling. But the totals have increased over time based upon an increasing human population in the United States. As with so many other issues we've discussed, including food, water, and land use, we as a society are thinking about the Earth's carrying capacity and what we want to use that land for. Do we want to use the land for making food and growing food, for developing new urban habitats, or do we want to use it for storing our trash? Because the trash has to go somewhere, and there are millions and millions of pounds of trash generated each and every year. So in the San Francisco Bay Area, we do have some notable landfills, and some of them have been closing because they've reached capacity, and others have had to expand in order to accommodate all of the trash of the San Francisco Bay. So a lot of San Mateo County trash ends up going to the Ox Mountain landfill, which is up in the mountains between San Mateo and Half Moon Bay. However, that landfill only has a few years left before it's going to start to reach capacity. And in the next decade or so, it'll probably have to be completely closed to allow that waste to slowly break down over hundreds or thousands of years. A lot of San Francisco County trash goes to the Altamont landfill in Livermore, as well as the Ostrom Road landfill, which is in Yuba. And that's quite a distance. There's actually a train that is being developed that will take the trash from San Francisco to this community near Yuba. So that kind of has some environmental justice issues where now the residents of San Francisco don't even have to think about it. They can just bring all their trash to the bins and then it all gets shipped 100 miles away. However, San Francisco is currently designated as a zero waste city. And in order to strive for zero waste, San Francisco politicians and city advisors advocate for state legislation and partner with producers to develop a producer responsibility system where producers design better products and take responsibility for the entire life cycle of the product, including take-back and recycling. And that's a big part of becoming zero waste, because when you're done with a product, if it can't go into a landfill, where can it go? So back in the day, when we threw things away, we just basically put them in big piles, or we just dumped them into the ocean. Before the 1970s, there was really no laws protecting our planet from those old styles of city dumps. But in 1970, the Environmental Protection Agency called the EPA was formed, and they started to make lots of laws over the next decade that regulated disposal, cleanup, and prevention of garbage. And the EPA really focused on making the polluters responsible for cleaning up their waste. Now, to connect this trash issue back to our very first case study, when we talked about sediment in the San Francisco Bay, well, landfills also shape the San Francisco Bay. Some of the places where some of us might live today is actually built on former landfill. A notable place is Foster City, right on the edge of San Mateo, is built on old landfills from back in the day. Now, moving forward, trash will be placed into the landfills of the future that are going to be much more high-tech. Hopefully, these landfills will have zero leakage and will prevent contamination of the surrounding environment. In fact, some landfills can even use this landfill juice, which is the leached chemicals and decomposing materials that come off of a landfill. Well, we can take this landfill juice, collect it, and treat it, and sometimes even use it to generate energy. So here are some objects on your screen, and I want you to think for a moment how long it takes for these things to break down. First off, let's look at the newspaper. A newspaper takes about 2 to 4 weeks to break down. It's mostly just paper. Next up, the banana peel. We often think of banana peels as being these organic things that break down easily, but in reality it takes 3 to 5 weeks for it to decompose, so that's quite a long time. A pair of socks, if we throw them away in the landfill, they take 2 to 3 years to break down. Any wooden items, such as this wooden chair, is going to take 10 years to break down in a landfill. Disposable diapers, while convenient, do take up to 50 years to break down in the environment. An aluminum can, if we don't recycle it properly, is going to take 300 to 400 years to break down in the landfill. A plastic water bottle takes 500 years to break down. And any styrofoam containers, such as to-go containers you might get from a restaurant or somewhere else, will never break down. Styrofoam will not break down. It's going to be on our planet for the rest of history. So what's being done? You might see headlines in the news from time to time, and there are many different technologies that are being developed to help us address these trash problems. And you, as an environmental scientist, might forge your career in addressing these landfills of the future. Another place our trash ends up isn't in these landfills, but it's in the ocean. And a sad example of this is what is called the Great Pacific Garbage Patch, which is abbreviated GPGP. It's a trash vortex in the northern Pacific Ocean that's about the size of the state of Texas. Now, there is a lot of plastic floating in the ocean, so some students and scientists are trying to design ways to clean the ocean, but is this just a fix or a temporary band-aid for this problem? I would say that we really need to address our plastic consumption lifestyle and try to eliminate plastic from our lives as much as we can. Here's a thought question about trash in the Great Pacific Garbage Patch. What implications do you think this trash has for organisms in the Pacific Ocean? And why do you think so much plastic ends up in the ocean and eventually in the garbage patch? These questions are going to really force you to think about our previous case studies when we talked about water and environmental systems and biodiversity. So I'm sure that from listening to this lecture, you realize we need to generate less trash. And you've probably heard of the 3 R's, but we've really expanded the 3 R's nowadays to include more priorities. The first priority is reduce. If we can reduce our consumption, then we will reduce our waste and the environmental hazard in the first place. Now, if we still need to consume something, then try to reuse if possible. By reusing existing resources, we can close the loop on this flow into a landfill. The last priority is recycling or composting. That comes after reduce and reuse, because recycle and compost still takes a lot of energy in order to take these materials away from us and reprocess them into something beneficial. Finally, disposal is the last and least desirable option. And this recovery and disposal option is where so much of our waste ends up going. So we often think we're recycling, so we must be doing a good thing. And it's true. If we didn't recycle, we'd be in really rough shape. However, a lot of things that we recycle unfortunately end up in the landfill because there's not a lot of places anymore that will take our recycled goods and process them for us. We used to ship almost all of them to China, but China is starting to say no, we do not want United States waste. San Mateo County has what's called a single stream recycling system where you put everything in one bin, your papers, your plastics, your aluminum, and then it gets sorted out by a complex machine that is found at local processing plants around the San Francisco Bay Area. Now, when we look at plastics, we often see a little triangle with a number in it. But just because we see a number in the triangle doesn't mean the plastic can actually be recycled in San Mateo County or elsewhere. Now, most plastic is actually downcycled, meaning that unlike materials such as pure aluminum, plastic loses valuable properties and strength the more it is recycled. Unfortunately, there is no hard and fast recycling rules around plastics, and they vary by region and county. And a lot of communities around the United States lack the resources to handle many different types of plastic recycling. So this graph shows us some recycling rates of selected products over the last decade, and some of the products are actually being recycled quite well. Things like auto batteries, things like newspapers, things like steel, that actually gets recycled because it has a use where we can use it to make more products, we can use it to make more paper products, etc. But plastics, because they downgrade so much, often don't get recycled very well. Notice down here, PET bottles and jars, which is a type of plastic, less than 30% actually gets recycled. Another concern with our plastic lifestyle is called BPA, which is bisphenol A. And this BPA has been linked as a known hormone disruptor. And it can actually leach into food products or beverages that are contained inside of these BPA containers. So it is important when you're shopping for plastics to find plastics labeled as BPA free. And of course, composting. A lot of our waste is compostable, and a lot of that sadly ends up in the landfill. It's really important to get this compost into the correct bin. In fact, here at College of San Mateo, we now have composting in many of our buildings, including our College Center Building 10, which is the center of campus. And it's really important that we get our compostable food items into those correct bins. So now let's talk about air quality and how air quality is going to affect our health, and if it's possible to have zero impact in relation to our air. So have any of you ever heard about a Spare the Air Day? San Francisco has been identified as having especially poor air quality in ground level ozone and particulates. We have stations set up all over the San Francisco Bay Area to monitor air quality, and therefore we can alert the citizens when too many particulates get into the air. So we spare the air when it's too hot and when it's too cold in the San Francisco Bay Area. When it gets really hot, things like volatile organic compounds evaporate into the air and can cause some really bad respiratory problems. These volatile organic compounds often evaporate from certain chemicals, such as burning fossil fuels, through vehicle emissions, pumping gas. You can actually smell those hydrocarbons in the air. Now, also when it gets too cold, because a lot of people, especially in the San Francisco Bay Area, have wood-burning stoves. And while we might think that wood-burning stoves are good for the environment because we're not using fossil fuels or other sources of fuel, it can actually be a problem because too much particulate matter from burning is really bad. We've also been having severe fires in California over the last few years due to global climate change, and these forest fires also contribute huge levels of particulate matter that causes lots of respiratory problems for our citizens. Around the world, there are global air quality issues, and a lot of it has to do with PM, which is that particulate matter. And we can see that in China is where most of the problems are. What are the major sources of air pollution? Well, we can break those down into two groups, both point source and non-point source. Point source is an identifiable source. Think about something like a company that is generating mercury waste, and then they're just pumping that into the bay. So that company is somewhere we can point at them and say, stop dumping from your factory into the bay. A non-point source is not so identifiable. Think about air pollution from cars. There's not just one car that we can identify that's causing the problem. It's the collective emissions of all of those cars. Also think about plastics in the Great Pacific Garbage Patch. There are many sources and not one identifiable source. So what are the major pollutants that we need to be concerned with in regards to air quality? These that you see on your screen are called criteria pollutants. And the criteria pollutants are pollutants that the Environmental Protection Agency thinks pose the greatest health hazards. Not necessarily because they are the most poisonous, but because they are bad for you and they are very common. This includes things like sulfur dioxide, which is the cause of acid rain and is naturally found in coal. It's released when we burn coal. Nitrogen oxides. These are contributed mostly by fertilizers. Carbon monoxide. It's a colorless, odorless gas that is emitted from fires, cars, and the incomplete burning of organic compounds. Particulates is PM, or particulate matter. This is of particular concern because these very fine pollutants, such as metals like lead, can get into our lungs and cause lots of problems. And then, of course, lead, once it gets into our system, is very difficult to get out. So one issue that is caused by some criteria pollutants is smog. And smog is the combination of smoke plus fog. This term was first used in the early 1900s when the Industrial Revolution was going on, because this mixture of smoke and fog produced unhealthy air. Additionally, we can have photochemical smog. This is a reaction that involves sunlight, nitric oxides, and volatile organic compounds. And this photochemical smog is directly related to automobile use. Now, these criteria pollutants can cause some major problems for humans. It can cause toxic poisoning, cancer, birth defects, eye irritation, and irritation of the respiratory system. Criteria pollutants can also cause an increased susceptibility to viral and bacterial infections for humans, and also an aggravation of chronic diseases such as asthma and emphysema. So what can we do to prevent poor air quality? Remember the 3 R's. Reduce is first. The most reasonable strategies for control have been to reduce, collect, capture, or retain the pollutants before they enter the atmosphere. The reduction of emissions through energy efficiency and conservation measures is preferred. One of the number one strategies is to discourage automobile use and reduce the number of cars on the road. Also, stricter emission controls for automobiles is key to preventing poor air quality in the San Francisco Bay Area. All right, so let's look at a conclusion on, is it possible to have zero impact? So in addressing this question, is it possible to have zero impact? We've now looked at the urban habitat, our water consumption, our trash bins, and our air. And now let's think about who is impacted the most. Now, it is true, we might say we're all impacted because we all live on one planet and breathe the same air, but some people are impacted so much more. Remember environmental justice and environmental injustice? There is a disproportionate share of our population that lives near these point sources that are emitting air pollution or other types of pollution. And these communities are typically communities of color. It is something that must be addressed when we think about solving these crises in the United States. We must also think about environmental justice. Here are some facts regarding environmental justice in the United States. 2/3 of United States housing was built prior to 1970, and many of these homes have lead paint. Lots of low-income folks still live in these homes that contain lead in the paint, in the pipes, and the soils. Low-income and quite often culturally diverse populations are more likely than other groups to live near landfills, incinerators, and hazardous waste treatment facilities. Regarding air pollution, urban areas are much more likely to have poor air quality. 57% of all whites, 65% of African Americans, and 80% of Hispanics are estimated to be impacted by air pollution. Regarding pesticides, approximately 90% of the 2 million hired farm workers in the United States are people of color, including Chicano, Puerto Rican, and Caribbean blacks and African Americans. That's a lot of farm workers that are subjected to and may suffer from these pesticide-related illnesses each year that are used for conventional agriculture. Here in the San Francisco Bay Area, we actually have a Chevron gasoline and oil refinery over in the Richmond of the East Bay. And it is a huge producer of waste. And unfortunately, most of the community that lives around this refinery has a lot of health problems because of it. Remember what happens when you live next to these different refineries? You get all of these toxic chemicals in your body that can bioaccumulate. So here are some questions to get us thinking about environmental justice. If you were a jobless or houseless Richmond resident, what might matter more to you, jobs or health? What positive steps do you think Chevron could take to ease this conflict? And what positive steps might residents take in easing this conflict? For environmental justice in the context of Chevron, these are things that could be done. First, the community tries to work it out with the polluter. They try to enforce that Chevron collects this pollution before it is released into the air. But because Chevron refuses to do so, they have to next lobby public officials. After that, mobilize hundreds of concerned citizens, and finally get allies with the legal and scientific community that can eventually force Chevron to do the right thing. So as we've gone through this case study, we've thought about all of the services that we need for our quality of life. And we truly can't live without these services anymore. We've become accustomed to them in the United States. But we can reduce our carbon footprint. We can make small changes in our life to try to make the planet a better place. And to help us understand our carbon footprints, we will be doing an online assignment in Canvas. It's truly about personal sustainability. Issues like environmental justice requires many people coming together with a common goal to solve problems. Just as a lot of these systems bring us water, they handle our waste, and they supply us energy, it took huge political acts over 100 years in order to develop the systems that we have today. And we can come together as a collective effort to try to strive towards zero waste and make sure everyone has an equal opportunity for healthy living. All right, that's it for this lecture. If you have any questions, please send me an email, and thank you very much for listening.